Right, look my dear student, today we are speaking pressure in fluids. How is the pressure? When we will think about the pressure in fluids, yesterday we seen pressure in solids. Thumb is pressure's own iron nail. So, force of my thumb is perpendicular to nail which is sinking in log in wooden piece. Yesterday we see. Now look here, pressure. Pressure in fluids. Actually, what is fluid? That is important. Fluid, the substances that can flow. And which substances can flow, that substances are called fluids. Example, liquids and gases. Next. Solids exert pressure on surfaces. Already we see solid exert pressure on surface due to their weight. Solids also mean table, chair, log, ball, whatever. Solids exerts pressure on surface due to their weight. Likewise, the fluids also exert pressure as they too have weight. How solids exert pressure on surfaces or on substances, like that fluids also have weight for them. Fluids also weightful. Is weightless fluid, have you know? Weight contained by fluids also. So that weightful fluids can exert pressure on other surfaces, on other substances. That only we are talking here. They too have weight. Fluids also have weight. That's why they can show pressure on other. In a container, look here. In a container, fluid exert pressure. Look here. In a container, fluid exert pressure on the walls. Walls inner side, on the walls inner side of the container in all directions, in all four sides directions. In a container, four sides container, all directions, fluid can show pressure on container. Next, what is buoyant force? The upward force, look here, upward, not downward, upward. Okay, the upward force acting on a body when it is partially or fully. Partially means half sinking of knot. When you are throwing football in water, it will sink half and it will not sink half. Cricket ball when you are throwing, it will sink half, it will not sink half. That is called partially and fully. Some balls are there, fully they will sink. Immersed in any liquid. This is called buoyancy. Half inside, half outside, sometimes full inside. Also we call buoyancy. Which substances sink fully or partially. Next, cause of buoyancy. Why buoyancy causes? So when an object is immersed fully or partially in a fluid, force acts on it from all sides. When an object partially or fully immersed into the water, then four sides water particles can shows force on the object. Already I told you fluids have to show pressure. Fluids have pressure. So that a fluid pressure can shown on ball. They will show an object. Which object is partially or fully immersed in water. So water also weightful object. So water can show pressure on object which is sinking into the water. Right, four sides. The side forces being equal and opposite. In a container, water four sides. Container four sides water is there. That four sides water can show equal and opposite forces. They can cancel each other. The forces acting from up. Which force acting from up to go down, and look here, and down are not equal. Down to upside force there, up to downside force there. Which object you thrown in water, that object show force up to down. But in container which water there, that water can show force down to up. Which force is more? That is important. So downside force is more than upside force. Downside force is more than upside force. Then that object can sink partially or fully. Look there. From up and down are not equal. The force exerted from down is more. That is, it experiences net upward force. When downside force is more, it will show us net force is more from downside. Simple. Net means total. Activity to study buoyancy. Look here, 5 points written. Suspend a small metal cylinder to a hook. Suspend. Tie a small metal cylinder to a hook of spring balance. How much weight? 150 grams weight in air. Now lower it into water. That suspended cylinder, lower it into water. Water container. Now the weight of cylinder decreases. Weight of cylinder is decreases to 140 grams. And look here, it becomes lighter in water. You can carry easily. As we keep on lowering the cylinder, the weight lost keeps on increasing. When again you are pushing into water, look there, the weight lost keeps on increasing when you are leaving totally. But once fully immersed, the more loss in weight is not seen. After immersing fully, when that cylinder immersed or sinked fully into the water, that after you can't see, what you can't see, where is that? You not see the weight loss. It becomes stable now. After sinking totally, it becomes stable. And next, what is conclusions are there? Wait, I will teach you conclusion. Look there. Conclusion. Look there. As more and more cylinder is lowered into the water. As more and more cylinder is lowered, the volume of water displaced by cylinder keeps on When you are sinking more, look here, as more and more cylinder is lowered, the volume of water displaced by cylinder keeps on increasing. When cylinder keeps on increasing, displace also be increasing of water, and it becomes lighter and lighter. When you are putting cylinder into water again and again, I mean when you are leaving it, then water can displace from the container, and what's happening? Cylinder becomes lighter and lighter, weightless. Next, weight is when it is fully immersed in liquid. Look there, note the maximum loss in weight, full of loss in weight, maximum loss in weight, it is fully immersed in liquid. Cylinder when immersed fully in liquid. Next, factors on which buoyant force depends. Which factors? Two factors are there. One, density of liquid. Second, volume of object immersed in fluid. Volume of object immersed in fluid, main factor. Look here. Depends on volume of object immersed. What is that? As the volume of object immersed inside the liquid increases the buoyant force. When cylinder is going inside of water, when lowering into water, then buoyant force also be increasing. Also increases. But when the object is fully immersed, the magnitude of this, look here, when the object is fully immersed, the magnitude of this force, magnitude of buoyant force becomes maximum and constant. When cylinder fully immersed into the water, then buoyant force also increases. Sorry, the buoyant force becomes maximum and constant. After that, there is no increase in buoyant force because cylinder maximum sink in water. Next, depends on density. First of all, you want to know what is density. Density meaning measure mass per volume. Mass per volume. Take one stone. What is stone's mass and what is its volume? In how much space it was covered? In how much space? I mean how much space covered by that stone. That is called density. Look here, that only written. Mass per volume is called density. Relationship between the mass of the substance and how much space it takes up volume. That is called density. So here, look here. Depends on density of liquid. Liquid, how much is there? And cylinder, how much density contain? Look here. More is the density of liquid. More is the density of liquid. More will be the upward force. More is the density of liquid. More water there. Then more upward force will be there. More buoyant upward force will be there exerted by liquid. More liquid, more force. Less liquid, less force. Thank you.